Our Milky Way galaxy is a vast and awe-inspiring place. It's a swirling city of stars, gas, and dust, a cosmic metropolis teeming with activity. Our sun is just one of hundreds of billions of stars that call the Milky Way home. And like our solar system, the Milky Way is constantly moving and evolving. From our vantage point on Earth, we see the Milky Way as a band of light stretching across the night sky. This band is actually a view of our galaxy from the inside. We are looking through the disk of the Milky Way, edge on from our position about 2/3 of the way out from the center. Measuring the size of the Milky Way is no easy task. We can't exactly just stretch a tape measure across it. Instead, astronomers use a variety of techniques to estimate the Milky Way's size and shape. One common method is to observe the movements of stars within the galaxy. By carefully tracking the positions of stars over time, astronomers can create a map of their movements. This information can then be used to infer the overall structure and size of the Milky Way. Another method is to use radio telescopes to observe the distribution of gas and dust in the galaxy. These observations can also provide clues about the Milky Way's size and shape. Based on these and other observations, astronomers estimate that the Milky Way is about 100,000 light-years across. To put that in perspective, 1 light-year is the distance that light travels in 1 year, which is about 5.88 trillion miles. That means that it would take light 100,000 years to travel from one end of the Milky Way to the other. That's a really long time, especially when you consider that the universe is only about 13.8 billion years old. The Milky Way is just one of billions of galaxies in the observable universe. Galaxies come in a variety of shapes and sizes, but the most common types are spiral galaxies, elliptical galaxies, and irregular galaxies. Spiral galaxies, like our own Milky Way, are characterized by their spiral arms, which are regions of active star formation. Elliptical galaxies, on the other hand, are generally smooth and oval-shaped, with little gas and dust and little star formation. Irregular galaxies, as their name suggests, have no regular shape or structure. They are often the result of galactic collisions or other interactions. Compared to other spiral galaxies, the Milky Way is thought to be a fairly average-sized galaxy. However, there are some truly enormous galaxies out there. For example, the largest known galaxy is IC 1101, which is an elliptical galaxy located about 1 billion light-years away from Earth. This galaxy is estimated to be about 5.5 million light-years across, making it over 50 times larger than the Milky Way. The Milky Way, like all galaxies, is a dynamic and evolving place. It is constantly forming new stars within vast clouds of gas and dust, known as stellar nurseries. These stellar nurseries are some of the most beautiful and awe-inspiring objects in the universe. They are often illuminated by the light of the young stars that are forming within them, creating a breathtaking display of cosmic fireworks. At the same time that the Milky Way is forming new stars, it is also consuming other, smaller galaxies in a process known as galactic cannibalism. When a smaller galaxy gets too close to the Milky Way's gravity can pull the smaller galaxy apart, eventually merging it with our own. This process of galactic cannibalism is thought to be a major driver of galaxy evolution. Over time, the Milky Way has likely consumed many smaller galaxies, and it is thought that it will eventually merge with the Andromeda Galaxy, our nearest large galactic neighbor. This merger is expected to occur in about 4 billion years, and will result in the formation of a giant elliptical galaxy. The Milky Way is part of a larger structure known as the Local Group. This collection of about 54 galaxies are gravitationally bound to each other. The Milky Way and the Andromeda Galaxy are the two largest members of the Local Group, and they dominate the group's gravitational interactions. The Local Group is itself part of a larger structure known as the Virgo supercluster. This supercluster is a massive collection of thousands of galaxies that are spread out over a region of space about 110 million light-years across. The Virgo supercluster is just one of countless superclusters that make up the observable universe. The observable universe is the portion of the universe that we can currently observe from Earth. It is estimated to be about 93 billion light-years across and contains trillions of galaxies. Galactic collisions are not as destructive as they might sound. While it's true that individual stars within colliding galaxies can collide with each other, The vast distances between stars make such collisions extremely rare. Instead, when galaxies collide, they tend to pass through each other, their gravitational forces distorting their shapes and triggering bursts of star formation. These collisions can last for millions or even billions of years, with the galaxies eventually merging to form a single larger galaxy. The Milky Way itself bears the scars of past collisions with smaller galaxies, and as mentioned earlier, it is destined for a major merger with the Andromeda Galaxy in the distant future. These cosmic dances are a testament to the dynamic nature of the universe, where even the largest structures are constantly moving and interacting. Looking beyond our local group, we encounter a mind-boggling array of galaxies, each with its own unique characteristics. There are grand spiral galaxies with sweeping arms, like the Whirlpool Galaxy, M51, and massive elliptical galaxies that appear as smooth, glowing orbs like M87, home to a supermassive black hole. Some galaxies are actively forming stars at a furious rate, while others are relatively quiet, their star-forming days largely behind them. Some galaxies exist in isolation, while others are locked in gravitational battles with their neighbors. This diversity of galaxies is a testament to the complexity and beauty of the universe. One of the most profound discoveries of the 20th century was that the universe is expanding. This means that the fabric of space-time itself is stretching, causing galaxies to move apart from each other like dots on an inflating balloon. The farther away a galaxy is from us, the faster it appears to be receding. This discovery revolutionized our understanding of the universe and led to the development of the Big Bang theory, which posits that the universe originated from an extremely hot and dense state billions of years ago. The expansion of the universe also has implications for the future of the Milky Way. As the universe continues to expand, the distances between galaxies will increase, and eventually, the Milky Way will become increasingly isolated. While the Milky Way is currently on a collision course with the Andromeda Galaxy, this event is still billions of years in the future. In the meantime, our galaxy will continue to evolve, forming new stars and possibly consuming smaller galaxies that venture too close. The future of the Milky Way is also intertwined with the fate of the universe itself. If the universe continues to expand indefinitely, as current observations suggest, the Milky Way will eventually become a cold and dark place, its stars slowly fading away. However, some theories propose that the expansion of the universe could slow down, or even reverse in the distant future, leading to a big crunch, where everything collapses back into a singularity.
Contemplating the vastness of the Milky Way and the universe beyond can be both humbling and awe-inspiring. It's a stark reminder of our own smallness in the grand scheme of things, yet it also fills us with a sense of wonder and curiosity. We are fortunate to live in a time when we have the tools and the knowledge to explore the universe in unprecedented detail. Through the efforts of astronomers and space explorers, we continue to learn more about our cosmic neighborhood and our place within it. Each new discovery brings us closer to understanding the mysteries of the cosmos and our connection to the universe around us.
The study of the Milky Way and other galaxies is an ongoing journey of discovery. As we continue to explore the universe, we can expect to uncover even more astonishing secrets about these cosmic islands and their place in the grand tapestry of the cosmos. From the birth and death of stars to the collisions of galaxies, the universe is a dynamic and ever-changing place, full of wonder and beauty. By studying the universe and our place within it, we gain a deeper appreciation for the interconnectedness of all things and the profound mysteries that still await our exploration. So the next time you gaze up at the starry night sky, remember that you are looking at just a tiny fraction of the vast and awe-inspiring universe that we call home. Keep exploring, keep questioning, and never lose your sense of wonder.